And this minus minus, I could turn those into what? Plus 1 plus 1? I know that's going to be 0 over 0, so I know I need to do some algebra. So this is a complex fraction. So we'd probably start by trying to get these two together. You get a common denominator and put those together, right? That doesn't look too bad to me, actually. That looks okay. Now this one up here, I could do what? That's a plus 1? Same thing, but do you agree that that common denominator is a little bit uglier than this common denominator? Yeah? But it could still go. I mean, it could still happen. So what would you like to do? You want to try it yourself, or you just want me to walk you through one of these? You want to try it? Okay. I can't give you all day, so I'm going to give you let's see how far you can get by 2:05. It's about 6 minutes now. Yeah. See how far you can go in 6 minutes.
Do you know how I could use this to find, to check my answer to find
Yes.
the actual?
Okay, so you go to your your draw. I think it's the draw menu. No, go back to your graph.
Okay.
And then I believe it's on draw. I can't read that.
So it's F6. Okay.
Let me see here. Oh, wait. Hold on. Oh, you know what? Oh, you hold it where it was.
Okay.
Okay, now I can see it. Try math menu. Go to the left.
Okay.
There we go. Derivative.
Okay.
Yeah, go try that. Just hit it and let's see what happens. Now move at where you're going to put in -1.
Okay.
That'll be your x. You can just type it in.
Oh, really?
You can just type in -1 and hit enter.
Okay. Oh, gotcha. And then
0.
oh, sweet. Okay.
Is that what you got?
Yeah.
Yeah. That's it. So I saw that you were doing this, which is the military background probably, maybe. So in mathematics, this is actually the empty set, which is different than the number 0. No, I'm just telling you to tell you. But I know in the military they do that for 0. But in mathematics, that's an empty set as opposed to the number 0. Just FYI. If you have a question, you can raise your hand. I don't mind coming by and kind of taking a look at the algebra you're doing.
It's okay. Me and my wife had a discussion about that.
What's that? Oh, you did?
I don't see for the x towards -1. I don't see it going to long division as aesthetic.
No, you can factor this. Rearrange this. X squared plus 2x plus 1. Oh, you did it right there. Okay. And then they cancel. Okay, good. Now let x go to -1. What happens? You're there.
2.
0 over 2, which is 0. That's okay to have that. You're done. That's the slope. You need the equation. So now go get the equation. You should be coming up with 0 as your slope. So you went with this one, huh? This one looks bad. So how did you do this? You expanded the bottom?
Yeah.
+1? You can't put these two together. I think that's the one that was underneath here. Can't do that. You have to take this entire thing and put it here and here. Because this is a 1, right?
Yeah.
So you need the same top and bottom denominator. I think what you did is you wrote 1 here and then you slid that 1 underneath. You can't. It's kind of like this. If I have 1 over 2 plus 1 plus 1 here, right? I can't just slide that 1 underneath here. Right? I have to get the same denominator. Yeah, but that's this one right here. That's that one. What did you do? You expanded this? Oh, this plus 1 belongs under here. Okay. And then you put it together. Okay, so all right, now I see. All right, because I didn't see that. Sorry. So now, though, you need a common denominator. So you have to put this whole thing on the top and bottom. You get 0?
Yeah.
Good. You try both ways or just one?
Just one.
Just one. I think there's an obvious candidate here for the better one. I think the x goes to a is the better candidate. It's a lot cleaner. Still got another 2 minutes. Yeah.
I tried doing the other method to make sure I was correct.
Yeah.
It's gonna go 0, 0.
If we're getting 0 as the slope, then that means our tangent line should be flat, right? I'm going to put it into the graphing utility so we can check our answer.
Well, do my math right. I don't know here. Stuck.
Okay, hold on a second. All right, where are you?
Oh, so they did long division. And then I still have a remainder left.
This one should be on the bottom.
Is that what I did wrong?
Yep. Let me see, hold on. Because this was x plus 1, so you write that. You rewrite this as x plus 1 over 1.
Yeah.
And then when you flip, it joins the bottom, not the top.
Did that right here.
Yeah, but it's that way. You have this big ugly thing over x squared plus 1.
Yeah.
All of that over x plus 1. You look at that as being a fraction like this.
Right, then oh yeah, crap.
That's it. Everything will be nicer after that. Okay. I think that's sufficient time. So what would you like me to do? Would you like me to work through? We need to take a vote. How many of you want me to do this one up here? How many of you want me to do this one down here? Okay. I'll do the bottom one first because it's easier. All right, so on this one, I need a common denominator to put these two together. I'm going to go through this quick, okay? Because it's all going to be on video. There's my common denominator. I replaced that one with this. Since these have the same denominator, I can put them together. Limit, x goes to -1. When I combine the numerators together, right, with this addition, and put it in descending order, I'm going to get x squared plus 2x plus 1. I immediately am thinking that factors. I already know that factors, okay? X squared plus 1, then all of that over x plus 1. And what we can do is view this bottom piece as a fraction also. That way we don't get confused as to how things would flip around. Let me rewrite the numerator factored. It would become x plus 1 times x plus 1 over the common denominator, x squared plus 1. Now, flipping this up, right, division of a fraction, same as multiplication of the reciprocal, that would come up here as 1 over x plus 1. And I get one of these x plus 1s to cancel, which was the goal for that to happen. Which leaves me with a final result. Limit x goes to -1 of x plus 1 over x squared plus 1. And now I'm going to let x go to -1. So -1 plus 1 is 0 over 2, which is 0. So the slope of the tangent line is 0. That was pretty clean. The other one, a little worse. So when you work this other one, you have to make a decision. When you get this common denominator between these two, do you want to multiply this out and figure out what all this stuff is first and then introduce that here and here? Or do you just want to take this and introduce it here and here? And that's up to you. All right? The way I do it, and this is just the way I do it. I mean, it's not right. It's not more right or anything. I'm going to replace this with just what I see. -1 plus h squared, right? That's this, plus 1 on top, -1 plus h squared plus 1 on the bottom. So I've replaced the 1 with that, right? Now when I put the numerators together, that's this plus this. It'll look like limit, h goes to 0. I have 2 times -1 plus h. Am I missing something there? No, that's all it was. Plus Negative 1 plus h squared plus 1, all right? That's what I have there. Those are your two numerators together. Over your common denominator, which is negative 1 plus h squared plus 1. All of this over h, which I can look at as h over 1, so I can flip it up on the next line if need be. That clear? Now I have to get an h to cancel, right? I mean, it's going to have to somewhere. So I need to actually expand that all out, figure out what happens. So I'm going to distribute a 2 through. I'm going to expand that and add the 1. So I should get limit h goes to 0. Negative 2, right? Negative 2 minus, plus 2h. Then expand this times itself. You should get plus 1 minus 2h plus h squared, then plus 1. And that's over our common denominator. Notice I'm not multiplying out the common denominator. I'm just leaving it. And then this, I'm going to flip it and make it times 1 over h out here. And if there's any justice in the world, a lot of things are going to go away here. Like this, 1 plus 1 is 2, but then you take away 2, so that's gone. Oh, wow. 2h, negative 2h. All I'm left with is h squared, right? And I can cancel one of the factors of h. And that's it right there. Yep, I'll have limit h goes to 0. I have h on top. I have negative 1 plus h squared plus 1. And if I let h go to 0 now, the top goes to 0. And the bottom goes to, let's see here, this is 0, so negative 1 squared is 1, plus 1 is 2. Same answer. Yeah.
I see that this one has a little bit more room for error.
Probably. I agree. But I also didn't have to know how to factor. Right? The other one I had to know that x squared plus 2x plus 1 factored, which you should know, but I mean, there's give and takes for both formulas. That's why I do not recommend that you just say, you know what, I'm an h go to 0 person, that's all I'm ever going to do. You want to be flexible because you could run into some problems where the algebra is just really ugly one way, very simple the other way.
So you're going to do
I would always recommend trying both methods just to get a feel for, like, it'll help you recognize like when to like back out of one and go to the other one. Because on the test, I will not tell you like which method to use, right? And you should be ready for both.
But you said that this method is more common.
Yes. In the next section, you'll see why. So I thought we would have a little bit of video time. It's going to be about a 2-minute clip. Come on in. Perfect timing. Let's see if I can find it. Oh yeah, by the way, that's the graph. We never found the equation of the line. I better do that first. What was the equation of the line? We do y minus y1 equals m times x minus x1, right? M was 0 though. So the whole right side's gone. It doesn't matter, right? I just need to know what y1 was. What was y1? Negative 1 equals 0. Y plus 1 is 0, which means y is negative 1. And we know that when we're talking about lines, if it says y equals a constant, it's a horizontal line, and it passes through this y value. So you can see this blue line right here. That's it right there. See it? It's hitting at negative 1, tangent to the curve. The more interesting question would have been, and this is where we're headed with this, is I give you this curve to begin with, 2x over x squared plus 1. And I ask you to find its highest and lowest points. Right? That would be a more interesting problem. Do you agree? You would say, this is all you have, and from that you figure out on your own that negative 1 is the lowest point, and that 1, 1 is the highest point. We'll do that later, all right? Well, I think by the time we get to that, we'll understand what it is that it takes to get to that. So it's not that bad. It's just that's the more interesting question. We're leading into that. All right. So I'm going to show you this video, and then after that, we'll talk about the video. And if any of you have not seen Kill Bill Volume 2, I'm not here encouraging you to watch it. I'm also not trying to spoil anything here if you want to watch it. Yeah, it's kind of old. Here we go. Hopefully it's not too loud. Sorry, I was just reading that quote. This next part is the part I want you to see. I'll tell you when. Okay, right here. Okay, so what the hell is he showing us that for, right? I think he's lost his mind. That's already been confirmed. I don't know, there's something about that, you know, like when you're totally invested in something, when you're totally 100% invested in something, you can find yourself in the middle of the night waking up thinking about it, you know? Right? I mean, that's what she's doing. She's punching shit in the middle of her sleep, right? Because that's all she's focused on. So I don't expect for everyone here to get to a point where they look at calculus that way, where they're waking up, they're like, you know, limit h goes to 0. F of x equals h, right? But you need to be somewhat focused on this. And especially that quote where it was, you know, something about, you know, if you're already defeated, you know, what's the point, right? I mean, you have to believe that you can do this sort of thing in order to do it. So I'm just trying to encourage you to, like, you know, commit to this stuff and you will be rewarded for committing to it. If you act defeated and you don't put in the effort and you don't go do the problems, you don't get in the algebra and get your hands dirty with the algebra yourself, you know, you may as well not be there. So, I don't know. Okay. We should do more examples. So how bad can the algebra get? Funny you should ask. Well, there's really no limit to, no pun intended, there's no limit to how bad. So let's do equation, tangent, line of the function f of x equals
that they combine this with logarithms?
Oh yeah, we could have logarithms in here. You could theoretically right now, this works for any function. right? I'm sticking pretty much to polynomials and rational functions, but some root functions also. Don't worry, we will talk about that. We're just not there. Yeah. Okay, so here's the function. I have to be careful that I don't go too far. If I push it too far, then the algebra will get to a point where we can't do it easily. So let's go with this. 3 over the square root of 4 minus x at the point 3, 3. Now I'm going to work through this whole one, okay, this whole problem, just because we could sit here and let you, suffer with it for a while and beat yourself up and do the algebra. That's what you're supposed to do at home, all right? You're supposed to suffer there and get your hands dirty. Here, I need to just show you, something where you can see it nice and fluid the way it's supposed to work. So let's pick at least a formula. I'm going with h goes to 0. I can't tell you why. I'm going for it, okay? So I'm going to go limit f of a plus h. What's a? 3. So 3 plus h minus f of 3 over h. I might back out of this in a minute. After I see the algebra, I might back out and go with the other one. We'll see. This is equal to limit h goes to 0 of, all right, I'm going to go in, I'm going to replace x with 3 plus h, right? Into my function. So I get 3 over the square root of 4 minus, in parentheses, 3 plus h. That is 3 plus h being plugged in right there. Yeah? Yes? Okay. Now what? Minus f of 3, right? Minus f of 3. What's f of 3? 3. Just so happens to be 3. So just minus 3. All of that divided by h. Now, I am kind of lucky in the sense that this does clean up a little bit, right? I can do 4, take away 3, take away h, and just get, what, 1 minus h? I could do that. I might do that just because it'll make everything look nicer. I went ahead and turned this 3 over here into a 3 over 1 because of where I'm headed, right? Where am I headed? Common denominator, then probably after that, maybe the conjugate? We'll see. Limit h goes to 0, root 1 minus h, minus 3 times root 1 minus h over root 1 minus h all over h. So there's my 3 over 1. I introduced the root on the top and bottom right there. And now I can put those two together. See my limit? See how it never went away? Please make sure you're doing the same thing. All right. Well, can you combine 3 minus 3 root? I mean, these aren't like terms, right? So all you can do is just write it 3 minus 3 root 1 minus h. That's the best you're going to be able to do up there. And then the common denominator is here. And then all over the h. And what was your goal here? You wanted what to happen? The h to cancel. And right now you can't get this to cancel because there's no h up here yet. So conjugate, right? That was one of the techniques that we learned. If we saw roots, and we can try this conjugate. So I'm going to introduce over here a 1. And that 1 is going to be 3 plus 3 root 1 minus h, and 3 plus 3 root 1 minus h, and I get the pleasure of putting that together. Nine. Middle terms are gone, right? I don't have to worry about the middle terms. All I really care about is this last one. This times this. I know my answer is going to be negative. I'm going to have 3 times 3, which is 9. And then the root and the root, when they go together, they go away. So I'm just left with 1 minus h. But I need that in parentheses.
At the bottom, it's like also just be 3 plus 3 at the end of it.
Do what? Remember, do y'all remember what I said about the bottom part? What to do with this? Yeah, just leave it. Don't try and multiply that out. It'll make life more complicated for you. Just leave it as root 1 minus h, and then just in parentheses write this. Because this is not the part of the problem that's causing the issue, right? This part is not causing the issue, and you don't even care about anything canceling from here. You want this h to go away. So I care very little about that piece. H over 1 here. All right, are we all agreeing with what I have here? 9 minus 9 times 1 minus h? Clean that up. What is that? I don't want to write the whole thing over again. 9, the 9 minus 9 goes away. And just, is it positive 9h? Positive 9h. So I'm going to say all of this is really 9h. Right? That's all 9h. And then this h over 1, I'm going to flip it up as a 1 over h out here. I'm just saving myself room and time right now. This h and that h go away. Yeah. So this line I will write down, because I'll be ready to take the limit as soon as I write this next line. Limit h goes to 0 of 9, we said, over root 1 minus h, and then 3 plus 3 times root 1 minus h in parentheses. And now let's let h go to 0. If that's a 0, this is just square root of 1. Square root of 1 is 1. So that's just 1 down there. 9 on top. 1. Parentheses. We just said that that's a 1, right? So we get 3 plus 3? 6. So you get 9 over 6, which is 3 over 2. 3 halves. 3 halves is our slope. Now we're not done because we wanted the equation of the tangent line, didn't we? So let's get the equation, and then I'm going to see if we were right. So for the equation, I'm going to do y minus y1 equals m times x minus x1, which is y minus 3 equals 3 halves times x minus 3. Remember your x and y, your x1 and y1 it was a 0.33. So I'm just plugging in. We've had a lot of these problems where the x and the y were the same. That's just coincident.
Could we leave the answer like that on the test?
If I ask you for the equation of the tangent line, that is acceptable. If I say, what's the equation of the tangent line in slope-intercept form, you must solve it for y. So I would just get used to solving it for y. It's not that much trouble to do it. Distribute through first. 3 halves x minus 9 halves. So that's our distribution of 3 halves through. And then add 3 to both sides. You have to put those two together. Common denominator. All right, this is 6 over 2. Negative 9 over 2 plus 6 over 2 is negative 3 over 2. So yes, you must be able to add fractions in this class. minus 3/2. All right, there it is. Let's see. You feel good about it? Well, I guess I should be asking it myself if I feel good about it since I'm the one who did it. All right, we had 3 over the square root, what was it, square root of 4 minus x? There it is. And let me move out here so you can see it. 3, 3, it looks like 3, 3 is somewhere around here. In fact, I can have it plot a point for me real quick. 3, 3, solid. Let's see, there it is. See, there's 3, 3. And now I'm going to have it plot, was it 3/2 x? Minus 3/2 again. There we go. All right, we've got about 10 minutes. I don't think I have enough time for another example, but it's okay because I still have one little topic I want to talk about. And I believe I can go to my notes for this. It's at the very end here. I talk about instantaneous rates of change. So this whole idea of finding the slope of the tangent line, where's the notation? There we go. Okay. This comes into play so often, right? Finding the slope of this tangent line, that it has a special name. Okay? The slope of the tangent line is called the derivative of the function at a. The derivative. And if you ask someone who's taking Cal 2 what Cal 1 was about, a lot of them will say it's about the derivative. So this is the first time we're actually seeing that name. Okay? So if you start with a function f, all right, someone gives you a function f, and they give you a point a, we can define this thing, and this is the notation we use for it. This is the derivative of that function at a, but all it is the slope of the tangent line at a. That's all it is. It's what we've been computing with the new fancy name. All right? The derivative of the function at a. Now, since we know that the derivative or the slope of the tangent line is a limit, it is possible for a limit to not exist. Right? It's possible for a limit to not exist. And so it is possible that the derivative may not exist. So as long as it does exist, we will say the derivative is defined. This is the notation. A lot of times people will say f prime of a when they read that. So f prime of a, oh, that's just the slope of the tangent line at a. That's what you mean. This f prime of a, this derivative, represents the instantaneous rate of change of our function at a point in time. So what we were saying, the slope of the tangent line, that tells you how fast the graph is growing at that instant. So if your graph has, let's say you're in a chemistry class and you have time here and you have the temperature of something. So you do some mixture, some chemicals, and then you start graphing the time, the time versus temperature, or temperature versus time axis. So your temperature maybe starts out here and then goes up and then drops down like that. Let's say it does that. Then if you were being asked to find the derivative of this function at a specific point in time, like right here at a, then that slope, right, that derivative is telling you the instantaneous rate of change in the temperature with respect to time. So it would be like, let's say temperature was measured in degrees Celsius, okay? Celsius, degrees Celsius. And let's say time was measured in seconds. Then if we pick some point in time, let's say we pick some arbitrary point like 3 seconds, okay? The A is 3. And let's say we find that the slope of the tangent line here, f prime of 3, because A is 3, let's say that turns out to be 5. Okay, so that slope is 5. But in this chemistry class, what we would be saying is, at exactly 3 seconds, in this chemical reaction, the temperature was changing at a rate of 5 degrees Celsius per second. Celsius per second. It's always this unit divided by this unit. But it's a measurement at an instant in time as opposed to an average where you look at the, maybe a starting and an ending time. So this is a very general thing. You can do that for temperature and time. You can do it for force over time. You can do it for anything. This doesn't even have to be time. It can be temperature and volume, something like anything that you can relate with an equation, with some graph. You can always find the slope of the tangent line. So this extends into all fields of mathematics, into all the sciences, anything. Statistics, finance, anywhere where you have a function. You can talk about how fast it's changing at an instant in time. And that's useful. That's useful information. Because as a person who's, maybe this is a finance model, you're trying to figure out what point in time were we making the most money? Or not making the most, but when were our profits the steepest, right? When were we bringing in money the fastest? Then you can go back and say, well, what were we doing? Oh, we fired John that day. Remember that? Okay. Okay, so you know what I'm saying? You can start to make correlations within your model to what you're doing. I hope that makes sense. Now, in a very specific case, which applies a lot to physics, is this idea of instantaneous velocity. So all that this means is that if you just take a specific example where this is time and this is what we call linear displacement or distance, then if you look at the graph and you look at the slope of the tangent line, that has the unique characteristic of being representative of instantaneous velocity. Because velocity is like speed. Speed is distance divided by time. And I told you that the slope would always be this unit divided by this unit. So if distance is miles, time is hours, then it would be miles per hour. If distance is meters and this is seconds, it would be meters per second. It just depends again on the problem. So please be aware of that. If I throw a problem at you on Thursday, right, you walk into class and I say, hey, here's a function. Find the instantaneous velocity of this function at t equals 2. What am I asking you to do? Find the derivative, which really means find the slope of the tangent line with a being 2. That's all it is. So you just need to understand the language of it. If I ask you the word problem, how to translate that back into the limit, you choose your formula, right? Okay, I believe that should be it. I don't think that there's more here. Make sure for next class you do the homework. Take a look at this video for 2-2. And we'll come back and finish it up. Have a good day.
Your times on Thursday are really early, right?
I'm here in the mornings every morning, so I don't know. If you want to say really early, it's 9 to 11.